Hi, it's MP the tutor here, and today we're going to look at linear inequalities. But before we do that, I'm going to have a little wander into normal solving equations, and then basically it's the same thing but with an arrow. So let's have a little look at this. We have 3x plus 4 equals 22. So what I'm going to do to solve this to get x on its own is you first of all take away the 4 from both sides, so you get 3x equals 18. And then we divide by 3 and divide this by 3. So you get x equals 6. That's it. Nice and simple and solved. So 3 times 6 plus 4 would have been now 22. Now here we have on the right hand side basically the same sum, but this time with an arrow. So we do exactly the same. So we take away 4, take away 4. We get 3x arrow 18 divide by 3, divide by 3, x arrow 6. So as you can see, it is the same thing on both sides, other than instead of it being equals, we have an arrow. Now, what does that arrow mean? So if I have that x arrow 6, well, what that means is x is less than 6. So if I have an arrow, this is the less than side, this is the greater than. And if I had it the other way around, and also a line, this is a greater than or equal to, and this is a less than or equal to. So in reality, let's just do some numbers. 4 arrow 6. Well, this is saying 4 is less than 6, or 6 is greater than 4. Doesn't matter, they are both the same thing. If I had 5 arrow line 5, this is saying 5 is less than or equal to 5. So it's technically correct. But also you could have 5 arrow line 100. Well, 5 is less than or equal to 100. Technically all correct. The final, you could have also had it where instead of being 5 is less than or equal to 100, you could also have 100 is greater than or equal to 5. Both are the same thing. So let's have a little look at this one. So here I have 5 minus 0.5x is greater than or equal to 1. Now, there's a couple of ways you can go about this. I'm going to add 0.5x to both sides. So you have 5 arrow line 0.5x plus 1. Then I can take away the 1, take away 1, and then you have 4 arrow line, or 4 is greater than or equal to 0.5x. And then you can divide by 0.5 or times by 2. So we end up with 8 arrow line, or 8 is greater than or equal to x. Now that's one way to go about it. But let's go that 5 minus 0.5x arrow line 1. Now what we can do is I've got a minus 0.5x. So what I can do is if I times by minus 1 to everything, it flips all the signs. So the 5 becomes a minus 5 plus 0.5x, but then the arrow also flips its direction. So instead of being that way around, it's then gone around and goes backwards on itself and flips like that. And then the 1 becomes minus 1. Then I'm going to add 5x to both sides. So you get 0.5x, or minus 1 plus 5 is 4. And then I'm going to times by 2 to get x is less than or equal to 8. So they are the same thing, but if you end up multiplying by a negative or negative 1, it flips the fraction. So times or divide by a negative flips the fraction. Let's have a look at this next one. Well, here it's find the values where x plus 4 is greater than x squared plus x 9. So the very first thing I'm going to do is expand out that bracket. So we have x times x is x squared, and x times 4 is plus 4x. Arrow x squared plus x plus 9. So in this case, we have x squares on both bits, and all I'm going to do is take away x squared. So you just get 4x. Arrow of 4x is greater than x plus 9. Let's take away the x from both bits. So you get 3x is greater than 9. And then we just divide by 3. So you get x is greater than 3. Nice and simple. It's not too bad. So let's have a little look at another way of writing these what's called inequalities. And that's via something called set notation. It's kind of very similar to normal how you write it, but it's slightly more than that, where it's used to define things a bit more accurately. But normally, most of the time, you just do normal way of writing it. But let's have a little look at this. So here it's written x is greater than 4. So this is another way of writing the arrow in word form. But this bit here is what's called set notation. And this first bit here is defining that x is our variable. And then what does our variable say? Well, that means that x is greater than 4. So if I was looking at this in terms of a number line, then you'd have a circle which is open at 4, and then it goes all the way across like that. So here we have it drawn on number line and in various different ways. Let's have a look at this next example, where we have x is greater than 2 and less than or equal to 7. And I've written that in two ways, both with words and with inequalities. And as you can see, I've highlighted the word and. So I'm going to draw this on a number line. So you could have a circle and an arrow going that way. And then we have another circle at 7. And we have arrows going the other way. So those arrows continue in both directions. However, we want the area which is both greater than 2 and less than 7. So this is actually a limited area. Now, there's a couple of ways we could write this. We could write this as without, so your x is greater than 2 and less than or equal to 7. So here I've written it as a standard inequality without it being written in set notation. But you could write it in two ways within set notation. So we've got the squiggly bracket, we've got x over colon, x is greater than 2, and then we close that. And then we have this nicely curvy n. It's kind of like capital N, but like a U upside down, capital U upside down, more like. And then we have another bracket, x colon, x is less than or equal to 7. So that is one way of writing this in set notation. So we also could write this in another way of set notation. So you have that little squiggly bracket, and then you have the x colon, and then we have that 2x like this, 7, and you close by that little squiggly bracket. So it's a bit of a weird looking bracket. You have to be a little bit careful how you write it because that's not a normal bracket we often use, but it is that weird squiggly bracket, which is on the screen there. It is a little bit weird, but it's what they want in the A level. Before the new A level came out in like 2017, I don't think I'd ever come across using set notation. Might have done, but it wasn't a normal thing for me to use when I've done inequalities in the past. Even during an astrophysics degree, we just use normal inequality symbols. So let's look at this next question, where we have given your answer in set notation, find the set of values for x given 5x plus 6 is less than x plus 2, or 7 brackets x minus 1 is greater than 2x plus 3. So what we have to do first of all is we are actually going to work these out separately. So we have these two separate equations. So we have 5x plus 6 is less than x plus 2. Well, let's just take away the x. So you get 4x plus 6 is less than 2. Then I'm going to take away the 6. So we have 4x is less than minus 4. Then we divide by 4. So your x is less than minus 1. Let's do the other one. So you have 7 bracket x minus 1 is greater than 2x plus 3. Then we're going to expand out that bracket. So we have 7x minus 7 is greater than 2x plus 3. Then we might as well then take away the 2x. So we end up with 5x minus 7 is greater than 3. And plus the 7. So we end up with 5x is greater than 10. And then we divide by 5 to get x is greater than 2. Now we then need to link up our two separate inequalities with set notation. So we start off by writing kind of the first one. So we have that weird squiggly bracket, x with a colon, and then we say x is less than minus 1, and then we close that bracket. Now, we then need to use the word, well, the symbol for or. Now, in set notation, the symbol for an or is kind of a U, which also is sometimes given the word union. So it's basically the word or union. And then we have that other set notation, squiggly brackets, x colon, x is greater than 2. Close that brackets like so. And that is it written in set notation. I'm going to write above it, not in set notation. You can have x is less than minus 1, or x is greater than 2. So, not set notation. And this bit here is in set notation. So why don't you have a go now at exercise 3D? Some of the questions are asking in normal sort of inequalities, and then others are asking for set notation. They aren't particularly complicated, and normally in A level they'd actually be like quadratics or cubics or stuff like that. But the answer's now on the screen, so check your answers, and hopefully then I'll see you in the next video, which would be to do with quadratic inequalities.